The next question is like this. This is find the directional derivative of the following. This is the main question. So in that, the first part is phi is equal to, this is x squared yz plus 4xz squared at the point 1 comma minus 2 comma 1 along 2i minus j cap minus 2 into k cap. Okay, so this is the question, right? All right, so we know that the directional derivative can be found by first we need to find out the del phi. Okay, so del phi and multiply with the n cap, right? So first we start with the del phi. So del phi is equal to, this is dou phi by dou x into I cap plus dou phi by dou y into j cap plus the dou phi by dou z into k cap, right? So let us simply substitute now. So this is dou by dou x of the phi is nothing but x squared yz plus 4xz squared into I cap plus the dou by dou y of, that is x squared yz plus 4 into x z squared times j cap plus the dou by dou z of x square yz plus 4 into xz square times k cap. Okay, so we have this now. Let us differentiate. So dou by dou x of the first term is nothing but, we are differentiating with respect to what? With respect to x square. So this becomes 2 times xyz plus 4z squared. This is the differentiation of the first complete term with respect to x, all right, into I cap plus, next I'm going to differentiate with respect to y. So only in the second half the first term contains y, so the differentiation is x square z into j cap plus the last term we are going to write now is the differentiation with respect to z. So this becomes x square y plus 8 x into z into k cap. Okay, this is the differentiation of each of the term. So once you know del phi, I need to calculate the del phi at the given point. So if you look at the question, the del at the given point is 1 comma minus 2 comma 1. So I need to find the del phi at 1 comma minus 2 comma 1. So substitute x is equal to 1, y is equal to minus 2 and z equal to 1. So that means it is 2 into 1 into minus 2 into 1 plus the next term is 4z square, 4 into 1 square. Okay, this is the first, into I cap plus next one is x square z. So this is 1 square into z is equal to 1 times j cap plus next what we are going to do, we'll substitute the for the last term. So that is plus, this is x square, so 1 square into y is equal to minus 2 plus 8 into 1 into 1, right, times k cap. So when you simplify this, we are going to get, this is 4, 1 minus 2 and 1. Okay, 1 minus 2, 1. So this becomes 2 minus, and 4 cancel, so 0 into I cap. Then 1 into j cap. Okay, then we have this is minus 2 plus 8, so this is plus 6 k cap. This is the del phi. So in the next step, I need to, in order to find the directional derivative, we need a unit vector. So calculate the unit vector. N cap is nothing but, so there is a vector given in the question. So just check that the given vector is 2i minus j minus 2k. So we'll write that now. So therefore this is 2i minus j, this is 2i minus j minus 2k whole divided by under root, this is 2 square plus 4 plus 1 plus 4, so this is 9. So this is 1 by 9 times 2i minus j minus 2k. So this is the unit vector we got. Therefore the final answer is the directional derivative is nothing but, how do you calculate that? That is, whatever is the del phi you calculated, dot product with the n cap. So that is equal to, already we calculated the del phi, which is j cap plus 6k cap dot, this is n cap, which is, I'll just write 1 by 9 in the denominator, this is 2i cap minus j cap minus 2k cap divided by, sorry, this is root 9, my mistake. This should be, this is not 9, this is 3. Okay, divided by 3. So there is no I term, only j will come into picture. This is minus 1. So j into j is 1, so there is a minus 1. 6 into 2, 12 divided by 3. So the final answer, directional derivative is equal to minus 13 by 3 is the required answer. Okay, let's proceed. We'll solve another question of a similar type just to get familiar with this. Okay, so here the phi is equal to 4x z cube minus, this is 3x square y square into z at, this is 2 comma minus 1 comma 2 along another vector, that is 2i cap minus 3j cap plus 6 into k cap. Right, so the first step, like always, we have to take the del phi, correct? So what is del phi? This is dou phi by dou x into I cap plus this is dou phi by dou y into j cap plus dou phi by dou z into k cap. Okay, so this means basically what we are trying to do here is the same, the dou by dou x is being differentiate, there is a differentiation of the given phi, so which is 4x into z cube minus 3x square y square z into I cap, plus this is dou by dou y of 4x into z cube minus 3x square y square z into j cap, plus this is dou by dou z of 4x z cube minus 3x square y square z into k cap. Okay, so in the next step, now let us differentiate each of the terms one by one. So that means when I differentiate this with respect to x, I'm going to get 4z cube, and in the last term I'm going to get minus 6x y square z into I cap, plus next term I am going to differentiate with respect to y. So there is only one term which is y, right? So this becomes, if you see, this is negative, so this is minus 6x square into yz times j cap. Then we have plus with respect to z, so 4 into 3, 12x z square minus 3x square y square into k cap. Okay, so this is what is the term we are getting, but I need this del phi at a specific point. So what is the point? The point is 2 comma minus 1 comma 2. So substitute 2 minus 1 2 in this equation. Okay, so this is 4 into 2 cube minus 6 into x into y square into z. This is the first term into I cap. Then minus 6 into x square into y into z times j cap. Okay, then plus 12 into x into z square minus, this is 3 into x square, that is 2 square, into y square, that is minus 1 square, right, times k cap. Okay, now let us try to simplify this. So this is equal to, so 4 into 2 cube minus 24 is nothing but this is 8 I cap. Then minus of minus is plus 48, so this is positive 48 j cap. Then 24 into 4 minus, this is 12, so this is plus 84, this is plus 84 k cap. Now I need to find the unit vector, right? So what is the unit vector n cap? This is equal to, look at the given vector is 2 I cap minus, this is 3 times j cap plus 6k cap whole divided by square root of, this is 2 square, 4 plus 9 plus 36. So 36 plus 9 plus 4 is 49. So this is root of 49. So that's 7. So this is 1 by 7 times 2i minus 3j. Alright, so this is the unit vector. Therefore, the final answer is the directional derivative is calculated as del phi dot n cap. Alright, so let's do this. Del phi dot n cap is calculated like this. That is, del phi is 8i plus 48j plus 84 k cap dot 1 by 7 times 2i minus 3j plus 6k cap. Okay, so when we simplify this, this is equal to, so 8 into 2, 16, 16, then 48 minus 3, okay, then plus 84 into 6, that comes to be 376 divided by 7 is the directional derivative. Okay, let's go to the next question. Phi is equal to xz divided by x squared plus y squared at 1
Excuse me, sir.
comma minus 1 comma 1 along the vector a is equal to I. This is minus 2j plus k cap. Okay, so we want to find this. So let's start with the del phi. So del phi in this case is equal to, what is the basic equation to be used? That is dou phi by dou x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. So the first part is nothing but, let us substitute. This is equal to the dou by dou x of, this is xz by x square plus y square into, this is I cap, plus this is dou by dou y of xz by x square plus y square into j cap, plus dou by dou z of xz by x square plus y square into k cap. Okay, so let us differentiate. Now you see that this is a quotient, so we always have to apply the quotient rule to simplify. Okay, so the first part, this is on the left hand side I have del phi. This is equal to, the differentiation happens with respect to x, so z is a constant. I'll take the z outside into, right? So quotient rule is nothing but denominator coming first. So okay, I'll use this square bracket. Denominator is x square plus y square into differentiation of numerator. Numerator is only x now, so differentiation is 1 minus this, that's the first term, that's the numerator, into differentiation of denominator is x square plus y square. So what happens when you differentiate that? It's because differentiation happens with respect to x, so only 2x comes into picture, whole divided by the square of the denominator, so that is x square plus y square, the whole square. This is the differentiation of first term. I need to multiply by I cap. Okay, right? Plus the second term, differentiation happens with respect to which one? With respect to y. So that means I take the both x z, I'll keep it as it is because it's a constant. So differentiation is minus, right, something 1 by x is minus 1 by x square, so minus of 1 is nothing but this is xz whole divided by x square plus y square, the whole square, into derivative of this is 2y, because y square is there, so 2y into j cap. Then the third term, right, differentiation happens with respect to z. So z means z is there only in the numerator, so no quotient rule. It's simply x by x square plus y square into k cap. Okay, we got this. Let's simplify this and write it neatly now. So this means this is equal to, so you see the first term is x square plus y square minus 2x square. So this becomes y square minus x square. So z into y square minus x square whole divided by this is x square plus y square the whole square. Right? This into I cap. Then the next term, it is minus 2xyz whole divided by x square plus y square the whole square into j cap. And the last term is plus, this is x by x square plus y square times k. Okay, this is what is the del phi at any given point, but we don't want that because we want this to be present at a specific point. So how do you find out that? So that is del phi at a given point. What is a given point? This is 1 comma minus 1 comma 1. All right, so we will be substituting the values, like wherever I see z, that is 1 into this is y square, so that is minus 1 square is plus 1, and minus, that's 1 whole divided by that is 1 square plus 1 square plus minus 1 square, which is anyway that's 1, so whole thing into I cap. Then we have minus 2 into x is 1, y is minus 1, z is 1 whole divided by this is 1 square plus 1 square the whole square into j cap, plus this is 1 divided by 1 square plus minus 1 square into k cap. Okay, so now this is equal to, I see that this is 0, so this numerator comes 0, so this is 0 into I cap. Then minus 2 into numerator is 1, so this is plus 2 divided by 1 plus 1 is 2 square, so this is, I can write minus of minus, oh sorry, plus 2 divided by 4 times j cap. Then this is plus 1 by 2 k cap, so 2 cancels with 4 as 2, so you can see that this answer is nothing but this is equal to 1 by 2 j cap plus 1 by 2 k cap is the del phi. Now I need a unit normal vector, right? So therefore I first need to calculate, therefore the unit vector n cap is nothing but there is a vector given a divided by magnitude of e. So vector a is I minus 2j plus k divided by root of 1 plus 4 plus 1. So root 6. So this is equal to 1 by root 6 times I cap minus 2j cap plus k cap. Right? So the last step is to find the directional derivative. So the directional derivative, right? How do you calculate? That is equal to whatever del phi you calculated dot product with the n cap. So you can see that the del phi 1 by 2j plus 1 by 2k dot n cap is nothing but 1 by root 6 I cap minus 2j cap plus k cap. So this is nothing but, let's take a product. I'll take 1 by 2 outside. This is j cap plus k cap into 1 by root 6 into I cap minus 2j cap plus k cap. So I have to multiply only j and k. So 0, then 1 into minus 2 is minus 2, minus 2 minus 2 plus 1 is minus 1 whole divided by 2 root 6 is the required answer. Okay, right. All right, let's go ahead. The next question is as follows. This is find the directional derivative of the function that is x into y into z along the normal to a surface given. The surface is x y square plus y z square plus z x square equals to 3 at 1 comma 1 comma 1. This is the first part of the question. Then we have another question, also find equations of the tangent plane and normal line. Okay, this is the basic question. So let's try to solve this now. So how do you start? You start with the given phi. Phi is nothing but this is x into y into z. So first by default I need to find del phi, which is dou phi by dou x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap, right? So let us substitute. This is dou of x y z by dou x into I cap plus this is dou of x y z by dou y into j cap plus this is dou x y z by dou z into k cap. All right, so in the sense, since it's differentiation with respect to x, we have yz remaining into I cap. So this is xz into j cap. This is xy into k cap. Right? So now the next step is to calculate the del phi at a given point, that is 1 comma 1 comma 1. So everything is 1 here, so 1 into 1 is 1 I cap plus j cap plus k cap. Okay, so now we can see that there is a surface given, so let's denote that as a side that is equal to the given surface x into y square plus y into z square plus z into x square. And by default I always need the del of this particular surface, so I call del psi. So basically this is dou psi by dou x into I cap plus dou psi by dou y into j cap plus dou psi by dou z into k cap. So let us substitute now. So this is equal to the dou by dou x of the given surface, that is xy square plus yz square plus z into x square into I cap plus this is dou by dou y of x y square plus yz square plus zx square into j cap plus dou by dou z of x y square plus yz square plus zx square into k cap. Alright, so this differentiation is going to give me the following part. So whenever I differentiate the first term with respect to x, right, the second term will vanish. So the first term is y square plus 2xz into I cap. Similarly, plus the next term becomes z square plus 2xy into, this is j cap plus this is x square plus 2yz into k cap. Alright, so this is the del psi, but what I want, I don't want del psi, I need del psi at 1 comma 1. This is nothing but I'm going to substitute those values. So 1 square plus 2, so that is simply I can write this is 3. This is 1 square, 1 plus 2 into I cap plus everything is the same, 1 plus 2 into j cap plus this is 1 plus 2 into k cap. So 1 plus 2 is 3, so I have 3 I cap plus 3 j cap plus 3 k cap, which can be simplified further as 3 into I cap plus j cap plus k cap. That is del psi. So along this I need a unit vector, right? So therefore unit vector n cap is equal to, this is 3 into I plus j plus k divided by root of, right? There is a 3 coming out. So this is 3 into 1 plus 1 plus 1. So 3 cancels. So my answer is n cap is equal to I cap plus j cap plus k cap divided by root 3. Alright, so therefore the final answer is the required directional derivative is the del phi dot n cap. So del phi is I plus j plus k into 1 by root 3 times a plus j plus k. So I into I is 1, j into j is 1, k into k is 1, whole divided by root 3. So this is numerator is 3 by root 3. So the answer is equal to root of 3. Okay, now this is the first half of the answer. Then we have another question coming up in the same main question, that is equation of the tangent plane, right? So we'll do that. Equation of the tangent plane, right? What is that? That is capital A into x minus x1 plus b into y minus y1 plus c into, this is z minus z1 equal to 0. So already we know that the values of x1, y1, z1 are the given points x1, comma y1, comma z1. This is what? This is nothing but 1, comma 1, comma 1, already given, right? But I need to calculate the a. Okay, so this means a is equal to, look at the given surface, so that is dou psi by dou x at 1 comma 1 comma 1, right? So I am going to perform the dou by dou x of the given psi. So what is the given psi? Given psi is x y square plus yz square plus zx square, right? At 1 comma 1 comma 1. So I'll do that. So this means it is y square plus 2xz, right, at 1 comma 1 comma 1. So in the sense I am going to substitute xyz as 1. So this is 1 square plus 2, so that is equal to 3. So I got a value of a, which is 3. B is equal to the dou psi by dou y at 1 comma 1 comma 1. So that is nothing but dou by dou y of the same function x square y plus, this is y z square plus zx square. This needs to be taken a derivative. So that is going to be 2xy plus z square. Okay, at 1 comma 1 comma 1. So that means this is 2 plus 1. Therefore, this is also becomes equal to 3. Alright, let's proceed. Similarly, I need to calculate a C. This is dou psi by dou z at the point 1 comma 1 comma 1. So this is dou by dou z of the same function, that is x square y plus yz square plus z into x square. Right? So this is I am going to get 2yz plus x square at the point 1 comma 1 comma 1. So I am going to get 2 plus 1. This is also equal to 3. So I understand that all a, b, c are same. 1 comma 1 comma. Therefore, now I'll substitute in the above equation. Therefore, equation of tangent plane becomes equal to, now you see, x minus x1, right, into e. So this is 3 times x minus x1 is 1 plus b, that is also 3, into y minus 1 plus 3 into z minus 1 equal to 0. See, straightforward. I just have to find a b and c. Okay, this is the equation of the tangent plane at the required point. Now, very similar to this, now what we have to do, we have to do the calculation of the normal line. Okay, equation of the normal line. So how do you calculate that? That is x minus x1 divided by a, that is equal to y minus y1 by b, that is also equal to z minus z1 by c. Already we have calculated these values, simply substitute. So this implies the required answer is x minus 1 by 3 equals to y minus 1 by 3 equal to z minus 1 by 3. So this is the required equation.